Hey guys, welcome back to AI Insights Innovation, the one place where you can learn how to make AI work for your enterprise. This is where we talk about the potential of this technology and what works, what does not, and what's ongoing in the industry right now. I'm your host, Dave Linthicum, author, speaker at B-List Geek, and analyst with theCUBE Research. And joining me today is IBM, and we have some great players here. We have Elpida Tzortzatos and Nate Dotson. And they're both with IBM, and they're going to tell us all about their AI private cloud solution. So you guys have been asking for that, not only just understanding what it is, but what's out there and what's being offered. The number one question I get from everybody in the comments is, what is the best AI? So here we go. Now we'll start looking at the particular solutions versus answering in generalities. So let me go ahead and have you guys introduce yourself. So Elpida, you want to go first? Who are you? Where are you from? What are you doing?
Certainly, David, and it's a pleasure to be here. I'm Elpida Tzortzatos. I've spent most of my career working on the mainframes, including mainframe operating systems, and focused on bringing new workloads and technology to our IBM Z and Linux One servers. My current responsibilities include being the CTO of AI on IBM Z and Linux One, and really, just to answer your initial question in terms of what's the best AI, there is no best AI, but there is a fit for purpose AI. And hopefully that's what we're going to be talking about today.
Yeah, that's a great answer. And I think that's what I always tell people. And they're always a little confused by that. But I think at the end of this discussion, we'll understand it. So Nate, how about you?
Hey, David. Yep. Thank you for the introduction. And again, my pleasure to be here. To answer the question, I'm just like Elpida. There is no easy button. There is no best solution. There's a whole lot of different things which can come together to create what our clients and those out there are needing. But again, my name is Nate Dotson. I am with IBM for over 20 years. I've spent my entire career with the mainframe, IBM Z. Started deep in the technology as a computer engineer, microprocessor circuit designer, and timing coordinator. Moved through the ranks of doing some project management, and then these past 6 or 7 years shifted over into product management for the IBM Z brand, where I spent 5 years prior to this as the hybrid cloud product manager, kind of helping to drive strategy around mainframe systems and integrating into the private cloud and hybrid cloud. And now I am the principal product manager around the next mainframe system, which will be coming to market soon.
Wow. You guys have some pretty critical roles at IBM. I'm glad to have you have this kind of brain power on the show. You got to remember that the reason we're talking about this, and the listeners, longtime listeners, know what this is about. Ultimately, as generative AI is taking off like a rocket, started 2 years ago, people are looking at this platform, the ability to kind of look at this tremendous amount of value, and certainly the innovative differentiator that AI is able to bring. People are trying to figure out the best platform to make it happen. And while there was a knee-jerk response to go after a single platform direction, at the end of the day, the cost and the capabilities of the different options out there, the heterogeneity of the different platforms, are leading us down the road to understand different aspects of different solutions that are out there. And one of the things about private cloud AI systems is because private clouds kind of used to be an engineering project. That's no longer the case. And the ability to provide turnkey systems that are on equipment that you own seems to be the sweet spot for many organizations that are out there right now. And I'm getting more questions about private AI clouds than anything else. And obviously cloud, public clouds are in the running, and in small systems, and certainly the micro clouds that are starting to move out there. But this seems to be the sweet spot for many enterprises, and they're looking at this as a strategic direction for running their generative AI systems. That's why we're having this conversation. I think it's probably one of the more important conversations that enterprises are having right now, because the path that they set right now is going to kind of set the tone for the way they use AI for the next 10 to 15 years. So I'll throw this out to either of you. Describe your AI platform capabilities in general, and what are the core capabilities that you're messaging to the marketplace right now? I love that.
Well, Elpida, I'm going to take a quick stab at just doing a quick step back for some of those who are probably listening that are going to be like, mainframe what? IBM Z, what is that thing? And I think it's going to set a little bit of context for the importance and kind of that fit for purpose that Elpida had mentioned. And it's not often we have an IBM fellow in these conversations. I'm going to hand it off to her to go into a little more detail. But essentially, mainframe systems, You might think, what, dinosaur systems, something antiquated. That's not at all the case. These are 60-plus-year systems in terms of how long IBM has been having these out there, continually modernizing and bringing innovation all along the way to support crucial industries, the financial industry, travel, insurance, retail, and numerous industries over the years. And basically, this is a system that on an annual basis is processing trillions and trillions of dollars. It is mission critical to the fabric of the way that the world operates, billions of transactions per day. So whether listeners out there know it or not, many times a day, you may be having, your data flowing through mainframe systems. You may be interacting with those systems anytime you're on your cell phone, checking your bank, your amount of money in the bank. It's going through a mainframe system, making airline reservations, etc. So it's a crucial system. Now, that said, it's highly transactional, and it's a data serving just beast. So it's a very, fit for purpose in what it does, and it does it very, very well. And we think that we have a very, very good position for the way that we support AI and moving even more into large language models, encoder models, etc., on the platform to really drive value around those transactions and data that have been there for many years for very good reason. So, Pete, I'll hand it off to you to kind of build on that.
Sure. Thank you, Nate. And I couldn't agree more. I mean, if you look at our platform, which is a high volume transactional server, and the best out there in the industry, when we were first starting our AI journey some years ago and trying to think about how we can best serve our clients, we saw a lot of our clients really have a need for being able to leverage AI in those transactional workloads in real time. And we wanted to make sure that they had an enterprise-ready AI infrastructure that would serve and meet their needs. And if you look at really what's happening in the world today, things like instant payments, increasingly stricter regulations that require real-time anti-money laundering solutions, and the dramatic increase of online transactions that have brought with them an increased amount of fraud. All of these things have really brought real-time AI to the forefront. And for enterprises, implementing real-time AI into their mission critical workloads without impacting their SLAs, meaning without slowing down the transactions, is more critical than ever. And really the technology that we build on IBM Z from the Silicon App, that includes the hardware acceleration, but also that very robust AI ecosystem that we build on top of that hardware acceleration, enables our clients to apply AI in all of these use cases at the speed and scale that their mission critical workloads really require. But even if you look at batch workloads, such as clearing and settlement workloads, where these workloads clear transactions, the volume of transactions is ever increasing, and the time windows are shrinking as the industry is moving to same-day settlements. And even for these use cases, throughput and latency have become critical. And the AI acceleration that we've built on our IBM Z servers, starting with Z16 on our Telemon chip, have really provided the critical response times and scaling in terms of throughput for embedding AI and examining with AI each and every single one of those transactions. And at the end of the day, when we look at our clients before Z16, a lot of them, because of impact to their SLAs, they were only able to examine less than 10% of their transactions. But with Z16, they were able to examine 100% of the transactions with AI for fraud, for example. And as a result of that, what we saw, a lot of the banking and financial services clients were able to materialize and realize a lot of savings for their business, whether it was fraud prevention savings or whether it was impacting their revenue in a positive way because they were able to do things such as, say, reduce the number of credit card false declines. So AI is giving them the ability really to derive new insights out of their data that would help them deliver improved business outcomes at the end of the day. So our platform is built to serve our clients, whether they have transactional AI use cases, real-time in transaction use cases, or whether now they're looking at this new GenAI type of use cases where security of the platform, being able to secure both the data and the models, as well as being able to sustainably deploy a GenAI type of use cases in a power efficient manner is very important to them. Our IBM Z platform can serve all of those needs for our clients.
Yeah, I got some briefings a few months ago when I went out for the analyst day stuff, and it was just I'm just amazed at the progress you guys have made and kind of the advancements in the platforms, and right at the right time too. I think that everybody is trying to figure this stuff out, and the ability to kind of leverage the right platforms at the right time and do so in a sustainable and cost efficient way. And I think that everybody's looking at right now. It's not just solving the problem. We can solve the problem with lots of different, throw money at the thing, but the ability to solve it in an optimized way is kind of the missing pieces that all my clients and some of the enterprises out there, people who are listening to the show, are really kind of seeking right now. So core thing in my generative AI architecture class, we always struggle with the idea of integration, the ability to have these systems that are integrated one to another. It's a core capability of what AI systems need to provide. So, and I'll throw it out to both of you again. Describe your integration capabilities with the mainframe and other traditional IT solutions, and what specifically do you do that's different from the alternatives, and specifically looking about data interoperability, looking at ETL and data and streaming data capabilities. What's there to have these systems communicate one to another?
Yeah, that's a great question, David. And let me talk about a couple things. First of all, when we build these AI capabilities into our platform, it was very important to us that our strategy as well as the capabilities we built fit very well with our clients' hybrid cloud strategy and environments. And it was synergistic with the investments that they made in their hybrid cloud environments. So on IBM Z, for example, we built capabilities where we really embraced open source and model portability. So clients who had already made investments, let's say on training or building the models, or when it comes to Gen AI models, if they wanted to really leverage the hyperscaler environments when they're exploring Gen AI or building Gen AI models from scratch, that's fine. But then they have the ability to very easily take models that were developed and built in any platform and any framework, and deploy them directly on Z. And those models not only run on Z, but they're optimized for Z. For example, we support open standards such as Onyx that allows our clients to bring models from other platforms, deploy them on Z, and without any changes, have those models run on Z, optimized and leverage our infrastructure and our hardware AI acceleration. We wanted to make sure, again, that our clients have the most secure, the most scalable environment for being able to deploy their AI models close to the core and mission critical workloads. A second point for me is we had also clients. We had one of the biggest credit card companies in the world, for example, that not only deployed their AI models on our servers, but also brought some of the data that they had that was coming from other channels. For example, they had some private data, but they also were doing some sentiment analysis on the news of the day, for example, to make sure that some of the merchants that they were dealing with, there wasn't negative news, or whether those merchants was news about those merchants being fraudulent. And they had aggregated that data and replicated that data on bring it to IBM Z so that they can deploy the models on IBM Z on a secure environment and get the throughput and the scale from an AI perspective that they needed, that they couldn't get anywhere else. So from an interoperability perspective, we believe in model portability. We embraced open standards in that space. So clients can certainly develop and build their models anywhere, whether it's on public clouds or on distributor, for example, but yet they have the ability to bring and deploy those models so they can optimize on our platform, and they can also, but by the same token, they can also bring data from other sources and other channels on our platform. So the technologies and the capabilities that we support on Z, certainly that was a very key part of our strategy. Nate, I don't know if you have anything else to add on to that question.
I mean, probably just a little. I mean, you really said it, and I think it kind of circles back to kind of the initial question that David had. I mean, much like hybrid cloud environments and a successful hybrid cloud strategy, right? There is no one singular platform that's going to fill an enterprise's needs, and AI is hybrid, right? To get it right and to extract the most value, that's going to be hybrid. And much as you described, Elpida, our clients are looking for portability, flexibility, the ability to be agile and nimble in how they're deploying AI to not only many times as they're starting out, learn, acclimate, get comfortable with how they're going to leverage AI and identify where they can get the most value. But as they start to do that, to then be able to deploy that, and as you mentioned, in a secure, a very scalable, a very efficient manner becomes really, really important. And whether that's AI on the IBM Z mainframe, because that's where the transactionality and the data and the need for that low latency and performance resides, or some other platform, it really is looking to what their end goals they're trying to accomplish. And let's be honest, there is a gravity to a lot of this making sense in context of the mainframe because of the types of the data, because of the types of the mission critical workloads and criticality of what is there, to not be doing the AI off where there may be additional business risk and other things that you alluded to, but to do that where it's secure, more performant, and aligns to where that data is. Because the second you start to disperse some of the workloads or data, a whole lot of complexity can come into play. So we feel that as you look at it as the big picture, again, best fit. It makes a whole lot of sense to do AI in certain platforms at certain times.
I love the answer because we're working from the requirements to the solution, not the other way around, which is illogical, which is something I see happening a lot out there, and a lot of mistakes are being made. So let's change gears a little bit. So let's look at the AI training capabilities. Can you describe the AI training capabilities of your platform, including model training approaches, processes supported, and what are some of the things that makes you unique with your training processes and training mechanisms? Either of you can answer.
Certainly. So when you look at training, there's different types of training, right? There's training for traditional AI or predictive AI models. There's training for GenAI models. And by the way, the different AI models and the different AI techniques have different compute AI needs. For example, if you're training predictive AI models, the compute that you need is not as really big and large as the AI compute needs of training, let's say, large language models from scratch. So from an IBM Z perspective, certainly we provide frameworks, a lot of the popular open source frameworks such as PyTorch and TensorFlow. For example, we support a lot of the popular Python libraries for training predictive AI and machine learning and deep learning models. We also have on ZOS, machine learning for ZOS, that not only provides capabilities where you can manage the end-to-end AI lifecycle, but also it's tailored and optimized for our ZOS runtime application environments and provides very low latency and response times, as well as very high throughput when it comes to embedding AI into mission workloads. So there's different, as I said earlier, compute needs based on the type of AI models that you are training. And if I look at predictive AI models, yes, we support, as I said, our own AI framework as well as other popular AI frameworks to be able to do machine learning and deep learning model training. But when you look at GenAI, I would not say that a platform is positioned for doing GenAI model training from scratch. To do GenAI model training, you need loads and loads and loads of clusters. But what we do provide from a GenAI perspective, which is important to our clients, to the ability to take a base model, let's say either from WatsonX.ai or from Hugging Face. I know a lot of our clients are using both of those platforms to take base models, whether it's our own Granite series of models or other large language open source models out there. And what clients are looking to do is one or two things: either augment those models with RAG architectures, and a lot of times they're telling us they get a lot of what they need with RAG augmented either Granite series models or open source large language models, or to fine tune those models. So from an IBM Z perspective, our clients will certainly be able to deploy large language models at scale sustainably in a power efficient way, but also they're able to fine tune those models. So I look at a large language model fine tuning as training, really, or a subset of training. So we definitely support fine tuning and deploying large language models on a platform. As you know, with the next generation of our servers, we're going to be introducing PCIe attached accelerators, our Spire cards, that would give our clients to fine tune large language models on IBM Z as well.
Very cool. Nate, anything to add?
No, I mean, I guess the only thing I kind of would add, and LP to hit at it, again, it's not like we're claiming to be everything. And as you look at that larger, massive training of these huge models, that's not something our systems are suited for. And it really comes back to what do you need to accomplish for the business and what makes the most sense. And I think that's where, as Elpida mentioned, that fine tuning, the ability to start to bring in, personal, sensitive, protected data, maybe even your IP, your code, other things that you don't want to be exposed to the outside. Well, now you have the ability, as Elpida mentioned, with the hardware and the acceleration we're baking into our systems, to be able to do that, again, in a secure and trusted environment with little risk. So I think that's really where our edge and differentiation lies for our clients, is getting them to a place where things they said that they might not even, maybe they wanted to run AI against some of that data or transactions, but due to regulation or something else, they just couldn't. It was too much risk. It was too challenging. Whereas now they're like, oh, this may unlock a whole new path of value that we didn't have before. So yeah, I think it was a great answer for Elpida. And I think, again, it aligns to where it makes the most sense in context of the business requirement.
Yeah, I agree. So let's change from training to inference. So throw it out there again to either of you. Describe the AI inference processing for your solution. How does that work and what's unique with that solution?
So I have to say, when we look at in-transaction inferencing and scaling AI inferencing workloads for high-volume transactional sort of workloads out there, we're the best in the industry. We have heard from clients before we had developed our built-in hardware accelerator for Telum One, that they were seeing a lot of challenges in that space. And we designed specifically based on, what we heard from our clients, we designed this Telum One built-in on-chip AI accelerator to serve those workloads. The fact that accelerator is built right on chip on the same silicon as the cores is no accident, by the way. The fact that our client said they wanted single-digit millisecond response times, and they wanted to be able to really apply AI to thousands of transactions per second, that really required that we have an AI accelerator that shared the memory with the host, as well as these huge caches that we have for our cores. And really, we optimized this AI accelerator for very, very fast response times and very, very high throughput, meaning our clients could actually do thousands of inference requests per second. Actually, when we did some benchmarking, our servers can scale up to 3.5 million inference requests per second from a predictive AI perspective, which is very, very impressive. We know that our clients have seen the benefits of that technology because Our last IBM Z 16 program has been one of our most successful programs. We've worked with many, many clients with lots of different use cases. And by the way, in many cases, these were clients where they had tried to do some of this on other platforms and they couldn't. They couldn't get the scale. They couldn't get the response time that they needed. Now, if you look at AI inferencing, just like I said earlier, training has different compute characteristics based on the type of AI models that you're training. That's very true when it comes to inference as well. So if you look at predictive AI models, really their compute needs are less, their models are smaller. When you look at now a GenAI inference, the models tend to be larger, in the billion and trillion of parameters. The compute needs are larger, but also the characteristics. When you look at the SLA characteristics of both for predictive AI, some of the use cases where predictive AI models are really, really a good fit for, such as fraud or anti-money laundering or risk scoring, for example, or anomaly detection. Some of those use cases have requirements in terms of very fast, single-digit millisecond response times and high throughput. When you look at GenAI use cases, we usually talk about tokens per second and so forth. So we build two purpose-built accelerators to serve these diverse compute needs of the different types of AI models. So we have the on-build AI accelerator to really serve in transaction real-time use cases where a lot of the AI models that are being used for those use cases and are a good fit for those use cases are predictive AI models, but also large language models that are context embedding models, if you will. So our on-build AI accelerator on our Telum 1 and now on our Telum 2 chips is a perfect fit, and it's purpose built to serve those use cases. And then when we look at GenAI use cases and the compute needs of those types of use cases, with the next generation of our IBM Z servers, we'll bring into the market a PCIe attached accelerator that's uniquely suited to serve those use cases and to serve those GenAI inferences in a secure but also sustainable way. Our PCIe attached AI accelerator called Spire. It's a 75-watt card that is very, very power efficient when you compare it to other types of Gen AI accelerators out there in the market.
Wow, good answer. Nate, you were smiling earlier when I asked the question. You want to follow up with something?
I think, just to, add a little bit of flavor to what Elpida said, it's like, again, we have a very rich history at IBM of from the beginning of compute, bringing all types of innovation. And this is the case of us listening to the market and our clients, right? We didn't build technology for technology's sake. There was a real pain point. There was a real need. There was a real gap in terms of being able to have that 100% of the transactions covered in real time, so that you, me, and all the other people out there who are purchasing and doing things on a daily basis continue to have that performance, continue to have our purchases approved, etc. So it's a real issue that leads many of the clients that use our platforms to deliver customer satisfaction and a better experience for all of us. So I think that's a really cool instance of how we're able to use very new technology to really bring value to the masses.
Awesome answer. So one of the questions I get a lot about this infrastructure, since it is a private cloud infrastructure, and then we're going to end up owning a lot of the things that it uses. What about infrastructure utilization, specifically data sources using data governance capabilities, things like that? How are you guys addressing that? Again, I'll throw it out to either of you.
From a data governance perspective, I think data governance is very, very important, but not only to us from an IBM perspective, but only to a lot of our clients. A lot of our IBM Z clients are in regulated industries. And when it comes to AI, especially if you are going to, let's say, decide by leveraging AI whether you're going to approve or reject somebody for a loan, right? It is very important that you provide capabilities such as explainability of those model AI-driven decisions, making sure that you mitigate bias when you build those models, but also when you deploy those models, monitoring for drift and bias is important so that you can retrain, right, and refresh those models if you notice that you have some sort of bias in the predictions, or if bias creeps in higher, or there's drift. Also, robustness is very important, as this is as well as transparency and privacy, protecting our clients' data as well as the model IP that they develop. So to me, starting your AI journey and not thinking about AI governance is really not a good thing. AI governance has to be thought of, and it has to be thought of not only when you deploy the models, but all the way from the start, looking at the data that you're using to train or fine tune those models. Make sure that you have the right tooling to mitigate bias even within that data. And then when you build and evaluate those models, continue to have the right tooling to really look for bias and mitigate bias, as well as making sure that you have cleansed data and good data at the end of the day. And then when you deploy those models, to continue to monitor for those things, as well as being able to govern those models, have full transparency on the data sets that were used to train those models, keep track of different versions of those models, having the governance policies in place that give the different personas, the different personas, the right accesses in terms of who can deploy those models in production. For example, who can refresh a model if it needs to be refreshed, and so forth. And within IBM, our IBM portfolio, we have products and tooling that allow our clients to do that, such as watsonx.governance, for example. So being able to really throughout the AI lifecycle, as I said, starting with the data that is being used to train or fine-tune those models, to monitoring those models when those models are deployed, having the tooling to be able to do all of that is very important. And we continue to invest heavily in those capabilities.
Great answer. Anything to add, Nate?
Well, I mean, I think the other thing I would add is there's kind of another angle around the data. Again, and it kind of circles back to that hybrid nature of everything, is that it becomes very important that there's interoperability, the ability to share, the ability to have access to data, both to and from our platform as well as other platforms. Yes, the governance and all the rest is extremely important around that to ensure that we're protecting the security of the data. We're having accurate answers and responses that are coming back that are trustworthy. But then again, fundamentally being able to have access to that data. And that's why, again, much like with the open source ecosystem that Elpida was mentioning around our AI and how we're really supporting what customers are already doing, the same should be said from a data perspective, right? That we're providing the right means, whether that be APIs or other technologies, to have access to your data wherever that resides in a safe and a secure fashion. Is very, very important to having a successful AI strategy. So I think that's one of the other things that we really are embracing. We're not embracing, contrary to what people out there might think around the mainframe or other systems, this is not a proprietary ecosystem. Yes, there is a whole lot that's been built around these systems over the decades that it's been around, which means that there is some complexities and things that we have to do as we kind of open up more. But that's the name of the game. It's either you're living and you're playing, or you're dying a slow death because you're not able to open up and adapt to what users and technology is presenting out there. So we are one of those systems that's continuing to evolve. We've done it for many years, and we'll continue to do that to be a success for our customers in the future.
Looks like it. So compliance and security, that's probably the number one question that I get, besides what's the best AI? How do you do compliance and security on these systems, since it is the keys to the kingdom that's going to be innate to many of these models? It's even more valuable than data. So describe security and compliance approaches for this solution. Whoever wants to take it, it's fine.
Sure, I'll take it first. So from a compliance perspective, a lot of the governance capabilities that I talked about earlier, Governance, for example, getting model metadata, making sure that you have version tracking, making sure that you know what data sets those models were trained on, being auditability, being able to monitor for drift and bias and so forth. All of the tooling and capabilities in products such as Governance really allow you to meet the compliance requirements when around AI and AI models. Explainability as well. From a security perspective, our platform supports confidential computing, which is based on trusted execution environments, which is part of hardware attestation capabilities that we initially introduced with our IBM Z15 systems. And those confidential computing environments and containers were really leveraging that technology for confidential AI. So our clients can run their models in these confidential AI containers, leveraging our trusted execution environments, and the models will be protected as well as their data and be very secure. From an overall platform perspective, our IBM Z servers are revered out there in the industry as being one of the most secure servers. You know that we've designed quantum safe. We were the first quantum safe system in the industry when we GA'd our IBM Z16 systems. We take security very, very seriously, and we ensure that our overall platform is secure, in addition to providing these confidential AI containers where our clients can deploy their models.
Awesome.
Yeah, and I mean, what I would add is, again, security, compliance, regulation, our systems and the workloads and the data, that's no stranger. The industries which leverage it heavily regulated. You look at banking, finance, the rest, we have to deliver bulletproof, secure systems so that the data is secure and that we are adhering to and helping our customers adhere to all of the regulations that are out there. And as Elpida mentioned, whether it's quantum safe, whether it's, you look at what we did with the AI acceleration and have that embedded on our microprocessor. We do the same thing with encryption engines, compression engines, and the rest, which allows us to do this at scale in a very efficient way. And as you kind of look at some of the technologies that we brought, the ability to have pervasive encryption where all of your data, all of your workloads, both at rest and at flight, with this system are protected and encrypted, that is extremely important. So we have this just amazing framework due to, again, the years and years and all the industries and data that's resided there that make this a unique platform that's already suited and highly engineered around security and trust. So again, from a fit for purpose perspective, as you start to look at those transactions and that data, it just makes a whole lot of sense. You're going to want to do that AI in place in that private cloud on these systems.
Yeah, what I like, it doesn't seem to be an afterthought. This is something systemic to the way you guys have already done security, and you're just extending that into the world. So you're taking the best of breed security solutions, extending that into AI. It's just known to work on this stuff. So in other words, it just wasn't generated. It was created around this infrastructure. So tell me a bit more about the future of all this, IBM Z. How are you taking AI systems to the next level of performance? What kind of things going on in the back that you can actually tell me about?
I can tell you that at any given time, we're working on 3 generations of our Z servers. And if we look out, in the near term, as I said, the next generation of IBM Z servers will have enhancements to our on-chip accelerator with our Telum 2 chips, or I should say on-chip accelerators, because actually you can have up to 32 chips 32 chips in our server. So therefore up to 32 of these built-in AI accelerators. And we'll bring to the market and introduce our Spire cards, which are PCIe attached cards that are really targeted for GenAI workloads and GenAI inference. So to go back to your original question, what AI is best, even on our platform, you see that we have now 2 purpose-built AI accelerators. The on-chip accelerator, which is a great fit for in-transaction real-time AI use cases that really are implemented with either predictive AI or both predictive AI models and large language models that do context embeddings in these composite AI use cases that we see being developed out in the market space, where clients combine the strengths of both traditional AI models as well as large language models to get more robust, more efficient AI systems, if you will. And then for GenAI type of use cases, this PCI attached Aspire cards to be able to serve the needs of those use cases. But if I even look out farther in the future and you look at quantum computers and AI, for example, how do you leverage quantum computers not only to accelerate AI, but also to get better, more accurate results, better performance when it comes to AI models? We can see that we'll have hybrid AI models where you run part of the model on a classical computer and run part of the model on the quantum computer to really get better answers at the end of the day, more accurate answers. And we're looking to integrate IBM Z with quantum computers in the cloud. You asked initially, what do we think about hybrid cloud environments? And when you look at AI and quantum, it is going to be a hybrid cloud where you have the quantum computer on the cloud. You have IBM Z on-prem, for example, and you have both of those technologies work together to solve problems with AI that we cannot solve today. So we continue to bring state-of-the-art technologies. We continue to bring the best of IBM research when it comes to both AI and quantum and integrate it into IBM Z. And you're going to continue to see that in the AI space for IBM Z. Nate, I want to leave some time for you to add your thoughts as well.
I love being the follow-up, Elpida. But I mean, because you just laid out really this amazing sci-fi vision of where things are heading, of where they are going, right? And I think just to kind of bring it back a little bit is again, we have built this wonderful foundation, and we have a roadmap and a strategy with other organizations in this huge machine that is IBM to be able to deliver differentiated technology. But I think most importantly, where we are, again, thinking about these systems, the data, what happens on them, you also have to kind of take a step back, and we got to get people moving. We got to get them comfortable with taking advantage and leveraging AI, because the business outcomes and opportunity there is really, really big. And as they build the trust, that nice roadmap, that cool technology that we can start to integrate with, where the world and technology is going, we'll be able to fold right into that, right? And our customers and clients and those that are using the system will be ready to do that. So I think that's the most important part, is to also, encourage in the near term for people to, dip their toes in, to jump in. Don't be afraid to start taking advantage of AI, because we provide, at least in the case of again, our systems and what they're good for, a really solid, stable means for customers to just jump all in on it.
Awesome answer. So we're about out of time, but I'm going to ask one more question to both of you. Why should those in the market for an AI provider consider your solution?
Well,
lightning round.
Certainly we talked about purpose build and purpose fit here, and really they should look at their needs and their requirements at the end of the day. It comes down to what are the requirements are for the specific use cases. Actually, they should start with the use case and look at the return on investment that AI can bring to their business for solving a challenge that they may have, for example, for the particular use case. And then look at the requirements, right? Requirements for those use cases. And for use cases, as I said earlier, whether require very low latency and high throughput, whether real-time AI use cases. Really, IBM Z is a great fit service for those, and for GenAI use cases where our clients want to deploy a lot of these GenAI use cases at scale in a sustainable manner on a system that's one of the most secure systems in the industry, then those are the use cases that are a very, very good fit for our platform.
Nate, final words?
Yeah, I mean, I will second that. I mean, again, I'd say, two things. For those who already have mainframe systems and are taking advantage of them on a daily, it's a no-brainer. You should be taking advantage. It's lost opportunity left on the table if you're not taking advantage of those AI capabilities to add value, not only for your business, but for your end customers and users. And then on the other side, it's like, as companies continue to grow, build, expand, they might not need a mainframe system today, but in the future, there might be opportunity to where they leverage a provider. They might be wanting to get into the market for some of these smaller systems and grow and build into them. We've got a platform that's there and ready, given the right types of workloads and data, to be a very viable and a powerful solution. So again, I think like Elpida said, it depends. You got to let your business characteristics and needs drive where you go. And for what our systems do, they do it well. Open arms to come and embrace AI on the mainframe.
Absolutely. So where can the listeners go find out more about your solutions on the web beyond just IBM.com?
I mean, I don't know. That's probably the biggest place you go. IBM.com. We have plenty of resources that are out there. And then obviously it's like, you got Elpida's name, you got my name. There's a whole host of people. You probably can just start to Google, go on LinkedIn, and feel free to ask us questions. Elpida, what do you?
Yeah, we also have a content solution, AI on Z. There's a lot of information there. We have a lot of good demos that people can go out there. And the demos, by the way, are based on real business use cases that we worked on with our clients. So a lot of good information out there on AI on Z and Linux One content solution pages.
Check them out. A lot of smart people. A lot of smart people at IBM. I'm always impressed every time I go to a meeting or attend a briefing, things like that. So, Elpida and Nate, thank you very much for the opportunity to talk about your product. I think you guys did a great job in explaining it and the reasons for why people want to look at IBM. So, don't forget to like and subscribe. Don't forget to check out our other stuff on theCUBE Research, and don't forget to check out the other stuff we have out on SiliconANGLE as well. So. Talk to you guys later. Have a great week. Thank you very much. Bye.
Thank you.
Thank you.